Thank you very much, and good evening, everybody. I'd like you to cast your minds back, if you will, to the dawn of the internet age. Back in 2000, Yahoo had a problem. They noticed that email spam companies were using computer programs to automatically register for free Yahoo email accounts. And they were doing this so they could use these accounts to send bulk emails, spam emails to us all. And Yahoo obviously wanted to stop this. They needed a test. They needed a way to test whether a user registering for a free email account was a real human or a computer. And at the time, a group of researchers from Carnegie Mellon University came up with a clever idea called a CAPTCHA. Now, you all know CAPTCHAs as those distorted words that we're asked to decode when we sign up for an email account or register with a new social network. They're easy for humans to solve, but machines can't solve them. The CAPTCHA system is able to verify our answers by comparing the word that we enter to the word it knows was displayed. And these CAPTCHAs have become very, very popular. In fact, by current estimates, about 250 million CAPTCHAs are being solved every single day. Let's put that into perspective. 250 million CAPTCHAs by about 20 seconds of human problem-solving effort per CAPTCHA. That translates into about 150 years, person years, worth of effort devoted to CAPTCHA solving every single day. Wouldn't it be interesting if we could take some of that effort and use it to do more than just police free email registrations? Well, Google have a very ambitious book scanning project. They want to digitize every book that's been published and make it searchable. So 24/7, Google's scanning systems are poring over printed pages and converting scanned pages into text. But that conversion process isn't perfect. Even our smartest scanning systems still can't cope with the many varied forms of the printed word. So there are lots of errors. And normally these errors, these unknown words, would have to be fixed by hand. But you'll notice that recently, the CAPTCHAs that we are solving are two-word CAPTCHAs. One of these words is known to the CAPTCHA system for the purpose of verification, but the other word is one of these errors taken from the Google book scanning project. If the user gets the known word correct, the CAPTCHA is deemed to have been passed, and their guess for the unknown word is noted. So that very quickly, the CAPTCHA system builds up a huge database of guesses for millions upon millions of unknown words. And this proves to be very successful. When you look at the common patterns of guesses for these unknown words, they quickly converge on the correct word. It's about 99% accurate, slightly more than 99% accurate, in fact, and comparable to what professional human transcribers will produce. So it's a really good example of harnessing our innate ability to decode distorted words, but doing so by piggybacking on top of a routine online verification task. We love to play computer games. Every year, literally, billions of hours are spent by people playing computer games. What if we could harness some of that human effort to solve some big problems? Maybe some really big problems. Maybe some of the biggest problems that scientists are tackling today. In the world of molecular biology, one of those big problems is protein folding. Predicting how a protein molecule will fold into a functional three-dimensional form is important, but still not really well understood. And a game called Fold It has been developed that is designed to take advantage of our innate spatial reasoning faculties and at the same time help molecular biologists to better understand protein folding. So ordinary players of Fold It manipulate 3D shapes on a screen. They correspond to protein molecules. They twist and turn these shapes and fold them into more compact forms. And their efforts are scored based on how well they satisfy certain spatial constraints. And then scientists analyze the best solutions, the highest scoring gameplay, to look for common patterns that they can apply to real protein molecules in the real world. Turns out that Fold It is lots of fun. Players love to compete for high scores on the latest molecular shape-shifting challenges. But more than that, scientists are gleaning real insights from their gameplay. Only last year, the results of a recent experiment to decode a particular enzyme that had stumped scientists for more than a decade was published. And folded players help scientists to decode that enzyme structure after only 10 days of gameplay. So I hope you get a sense of some of the examples of how we can harness collective intelligence to solve some really big problems. We're looking at similar techniques in my own lab to build better search engines and recommender systems, for example. But where might this go in the future? Let's just think about some of the largest examples of human endeavor over the ages: the building of the pyramids, the construction of large skyscrapers, the engineering of the Panama Canal, for example. All of these efforts correspond to somewhere in the region of 5 to 20 million person-hours worth of effort. But people are spending 100 million hours playing Farmville every week. That's 20 Empire State Buildings worth of Farmville play. Our brains are these wonderful computational devices. We pack about 1 billion neurons into something about the size of a melon. It uses less power than our bedside lamp. Imagine what we could do if we could harness even a small fraction of these millions of brains at play. Imagine the big problems that we might be able to solve. Climate change. Build better traffic management systems for our congested cities. Maybe build a better healthcare system. And maybe, just maybe, build a better, safer, more optimistic world for us all to live in. Thank you very much.